Hello friends, welcome to my channel. My name is Fikret, and today we're going to talk about relatively new dynamic capabilities added to Databricks job orchestration. Databricks Workflows is one of the most popular orchestration tools that allows you to run your code sitting in notebooks, Python files, jar, and so on and so forth. Databricks Workflows also allows you to build multi-step pipelines where you can build dependency between the different steps. However, until recent months, this tool used to be static. What I mean by this is if your job has to do multiple tasks with similar function, for example, if you are ingesting from many different files into some bronze layer, then you had to literally build all these tasks one by one in a workflow design page. Sure, you can also create jobs using Databricks SDK and some other programming tools. But for the people who are more interested in building jobs in UI, that was a limiting factor. And because of that, many data engineers may use some other tools like Azure Data Factory. Great news is with the addition of new dynamic controls to workflow functionality, now you can build dynamic and complex pipelines using your data sitting in your metadata tables. I'm going to show basic functionality of two dynamic controls, namely for each control, which allows you to build iterative logic, and the if conditional control. Once we are familiar with the basic functionality, I'll show how you can build end-to-end metadata-based dynamic pipelines using these controls. Let's get started. Okay, I am in Databricks workspace, and here is the use case scenario. I am a data engineer who wants to build dynamic pipeline for multiple tasks doing similar work. So examples of that could be ingesting into bronze. I have created a notebook here, which is pretty simple. So it expects two parameters, source file path. So the basic location of my raw files, and the target table name. And based on that, it creates the data frame and writes into this target table. Let's go ahead and create a new job. Let's first explore the basic functionality for each task. For each is a composite component which has two parts. So outer shell, which allows you to specify collection of items that it's gonna to iterate through. And then you have to specify internal object or executable objects that will be run for each iteration. So I am in new workflow design canvas, and we have a new task added here. So I'm gonna name this task. And if I select task type, I can see many different task types like notebook, Python script. Many of them have been there from the beginning of workflow introduction. What I am interested in is for each task. And once I specify for each task, there are only two parameters, inputs and concurrency. So the inputs for each task can be supplied multiple ways. So one of the obvious methods is to hard code them inside inputs box. So for example, I have created JSON array with multiple items, and each item has a few properties like table name, data zone, and so on and so forth. And I can simply copy that to the inputs box. The other alternatives for supplying inputs for each task are job parameters, as well as output of another task, which we're going to explore shortly. The next parameter is a concurrency parameter, which allows you to specify a number of parallel threads that will produce this iterative task. By default, if you don't specify, this number equals to 1, which means that the tasks included in this loop will run sequentially. But in many cases, if you are dealing with independent processing, like if you're ingesting into a bronze layer, it makes sense to set this number higher. So because my JSON contains 3 items, I'm going to specify number 3 here, and we'll confirm. Okay, so as you can see, we have created shell for each loop, and now we have to configure inside control that will be executed for each iteration. So for each task can run many different task types, which we can see here. So you can run notebooks, Python, or run another job, which we'll explore shortly as well. So for now, I'm going to select notebook and specify the notebook that I demonstrated a little earlier. So that's bronze ingestion notebook. And then the next step is to specify your compute. I'm going to select serverless, and I'll specify parameters for this notebook. So I'm going to add 2 parameters that this notebook expects. So this is going to be table name. And now to specify values, I'm going to click this curly brackets box, which will open different dynamic expressions that I can specify. So what I am looking for in this case is to provide different elements of the JSON that I pass to for each task. To do that, I can use input expression, and here I'm gonna specify property name that I have included in my JSON. So in this case, I'm gonna use table name property, and then I'm gonna add another parameter. And this parameters will be for source file path. And I'm going to use source file path property name from my JSON as input value. I'm going to confirm and run my job. Okay, so my job has completed. So let's inspect the execution logs. I'm going to open the execution log related link, and that will open 3 tasks executed by my for each component. On this page, I can review properties that were part of for each iteration. So properties like table name, data zone, source file, and so on and so forth. And if I want to find out what happened within each notebook, I can click this link, and that will show you execution log for this notebook. Okay, now let's explore other ways of supplying inputs for each component. I'm gonna create job parameter. I'll name it table list, and as a value, I'll copy paste my JSON array. Oops. Once I created job parameter, I can use it as dynamic expressions for my input. So I'm gonna click this button for dynamic expression, and that will suggest a list of job parameters that I can use. So I'm gonna use this parameter that I created earlier and save my task. The biggest advantage of this approach is this allows you to create reusable and parameterized jobs, which you can call from other jobs. So you can basically treat your job as a function, reusable function, and define the parameters, and then basically build nested pipelines on top of that, which I'm going to demonstrate when I show end-to-end metadata pipeline. Another great way of supplying parameters for each task is to consume it from another task from your pipeline. One of the ways to achieve this is to call a notebook which prepares this metadata and then dynamically supplies it for each demo task. So let me show you in another pipeline that I already created. So this pipeline design is similar to what I have shown in terms of for each iterator. However, I have added another task here, which is a notebook type, which supplies the values. So let's first examine this notebook that is called from this task. So here is my notebook. I call it collect metadata. So as a first step, I create metadata tables, which contains 4 columns. So for bronze ingestion, I specify bronze as a data zone, and I have this different table names, and I specify different paths here. Because for bronze layer, in most cases, as you're not consuming the data from source table, I have NAs as a source table. And I have silver zone related items in this table. So here is how my table will look like. And then I have a code here, which basically converts the data from this table into JSON output. And here's a JSON output similar to what I have shown earlier. Finally, the last and the most important task of this notebook is to create task values property that will be used inside the pipeline. So I'm using dbutils jobs API for that, and this method requires 2 arguments. The first one is parameter name, and then I will use the JSON variables that we created earlier. So remember this parameter name that we are assigning this JSON value, because we'll be using this further down when we're building dynamic expressions. Okay, now that we know how notebook creates dynamic expression works, let's go back to the job design page. So again, we are calling that notebook. There's nothing special about that. It's just like ordinary notebook call. What is different this time, however, is the way we are supplying parameters for each component. So if I click outside shell for each component, you can see different way of supplying input parameters here. Let me remove this and create it from scratch. So if I click this button for dynamic expression, that will create this boilerplate code. Here I have to specify parameter name that I have created here. So I'm gonna use task list from here and confirm. Let's run this job as well. All right, my job has completed. Let's review the execution logs. So we have logs for 2 tasks, read metadata and the item iterator. I'm going to open the link related to last execution. And if I click for each component, which is called item iterator, it will open the page with individual task executions. Before wrapping up conversation about for each task, let me show you one simple trick which you might find handy, especially if you already have pipelines with number of tasks and you just want to include existing tasks into for each task. So let me create a new job and include bronze ingestion task. So let's say I have bronze. And I'm going to select the same notebooks that I have demonstrated earlier. I'm going to confirm. Now with this task selected, I have few commands available that are relevant for this task. So you can see clone task, which allows you to easily create a copy of this task, which could be handy if you are building pipelines with multiple similar tasks. Another command here is loop over this task. So if I click this, it will create that for each task shell around my notebook task. And of course, you have to specify all the inputs as well as come back and change your internal notebooks parameters from hard-coded to dynamics expression, like I explained earlier. All right. Now let's move on to another topic. So I'm going to explore conditional tasks that I mentioned at the beginning. So let me create a new job for that. I'm going to name my first task. And we'll select if-else condition task type. If-else condition task is not a composite task like for each task. And to configure it, you need to have dynamic expressions in condition box. So here I have condition box. If I select this, it will give me a list of dynamics expressions. Most of them are system expressions. So you can base your conditions on system generated expressions like start time of day, job name, months, trigger time, task name, so on and so forth. Like for each task, if-else condition task allows you to base your conditions on job parameters as well. To demonstrate this, let me move on to another workloads that I created earlier. So I'm gonna just discard this and open the conditional pipeline. And here I have created job parameters. So in this case, I am looking to get data zone, source file path, source table name, and table name parameters. And if I click on if condition task, here I can specify dynamic expression based on my job parameters. So let's say I want to execute bronze or silver notebook depending on the data zone parameters supplied to this job. So I'm gonna select data zone parameter here, and I can specify different logical conditions, comparison conditions. Let's say, so I want to compare my data zone to bronze value. And I'm going to confirm my task configuration. The next step is to configure the true or false conditions for conditional task. To do that, you have to add tasks. This is just notebook task pointing to bronze ingestion. However, if I expand the dependency box, you can see that, so let me expand this. There are two outputs from my conditional task. So one is called true and one is called false. So because I want to call bronze notebook when my condition evaluates to true, then I'm going to choose true output from this task. And if I click the next notebook task to call the silver, I'm going to select false condition from my previous task. All right, now that we know how iterative and the conditional tasks work in Databricks workflows, let's create end-to-end pipeline which will be based on metadata and will use dynamic expressions from this metadata to have a conditional execution. So let me open another job. So this pipeline is like the one I have demonstrated for each component, where we first create this metadata by calling this collection notebook, and then we pass output from this task to item iterator like this. However, internal tasks that I have included in this for each iterator is a job type. So I'm calling conditional pipeline jobs that I have described earlier, and I pass dynamic expressions from this iterator like data zone, source table name, and so on and so forth. So basically all the parameters that this child pipeline expects. Okay, I run this job and let's take a look at execution logs to see how our conditional logic has worked. So if I go to runs and open the link related to my last execution, I'm gonna click on for each related task. So let's first examine one of the jobs related to bronze ingestion. So if I open this link, you can see that the conditional task has determined its condition to be true and diverted execution to the bronze notebook. And if I open the silver related notebook, you can see that execution was diverted to silver related notebook. So in my case, it has failed because of some most likely parameter issues. So let's take a look. So my notebook has failed because in bronze notebook, I actually did not create a target table. But the important thing is that conditional task has worked as expected. All right, so that concludes our discussion today. To summarize, with the addition of for each and the conditional task to the Databricks workflows, you can now build sophisticated metadata-based dynamic pipelines in workflows. I hope this video was helpful, and if yes, please thumb up and subscribe to my channel. Thank you, and I'll see you in future demos.